everybody. Welcome to the Robotics Undergraduate Community Meeting for the winter semester here. We really appreciate everybody coming out, during the cold and, giving up your dinner hour to come join us. If you haven't already, feel free to sign in. Grab some hot chocolate, grab some candy. We're fortunate that our undergraduate coordinator Kayla has provided all this for us and did a great job to organize our meeting here. We run these meetings to just check in with our undergraduates because we're a new program, to give you a sense of where the overall program is. Also record it for the people online so they can get a sense, even those people that can't join us, get a sense of where we stand with the undergraduate program. And so hopefully that works. So welcome to our third undergraduate community meeting and second as a robotics department. And so here, I'll close that. And so this meeting is available both in person, thanks for everybody coming out, and virtually. And our presentations here will be recorded, so it's going to be available on the undergraduate website, just like the one for the fall was. And one thing that's really important to remember is that you are making history. Just by being in this room, you are continuing to make history with us at this very moment. Michigan robotics is really trailblazing. There's nothing like this that exists really in the nation, in the world. And so we really appreciate you going on this journey with us and being true pioneers. And so, just to give an overview of what we're going to talk about in with the run of what we're going to do for our meeting here, I'm going to pass to our department chair, Dawn Tilbury, in a second. She'll give you an overview of what the department looks like. I'm going to talk about the undergraduate program and what we're doing for the program. Then Kayla Dombrowski, who's our undergraduate coordinator, will talk about the advising and student support that we're providing. We'll have a fast forward of courses that are being offered by our robotics program, and then we'll open it up to Q&A, and we'll answer every single question that any participant has. Anybody who's joining our meeting has, both remote or in person, because we want you to have the most information possible to make the most informed choices, so you can have the best learning experience possible. So with that, I will pass to our chair, Professor Dawn Tilbury.
So let's get started. The Robotics Department, making history. We are the first robotics department in a big university like this. As Chad said, probably anywhere. I was in Abu Dhabi earlier this week. They're trying to set up a robotics department, and so they called us to ask how we did it. Now, there was a great panel of people there trying to help them what you need to do to start a robotics department, and they were really all looking to Michigan as a leader in this area. So why? Jesse's cheering. So why robotics? So many of you know, we've had a graduate program in robotics since 2014. We've offered master's and PhD degrees. So why should we start a department, and why should we start an undergraduate program? Well, we think it's really the opportunity to build a community around robotics and help define the discipline of what is robotics. Better serve the students, including yourselves, better serving the faculty, including us, and really be able to innovate and try new things. I mean, the new department isn't the only thing that's new in this program. And we'll tell you a little bit more about that as we go through, I think there. So we think that a robotics undergraduate program is the right way to get undergraduate students in robotics. If you'd asked people 5 years ago, what's the best way to be a roboticist from an undergraduate perspective, they might have told you should quadruple major in mechanical, electrical, computer science, and mathematics, and while you're at it, minor in psychology. Now, we are not going to put you through that many classes, but we're going to take the pieces of all those majors that relate to robotics and put them together into an undergraduate program to get you ready for careers in robotics or for graduate school in robotics. Now, when we started the robotics graduate program and the institute, we were working with voluntary service from the faculty. The faculty didn't belong to the Robotics Institute. They belonged to mechanical engineering, electrical engineering, computer science, et cetera. So now that they've moved to the robotics department, offering robotics courses is their full-time job. It's not something they're doing on top of other things. Serving on the robotics undergraduate committee is their full-time job, not their part-time job. So we think it's better for the faculty to really be engaged in the department. And this will give us the opportunity to really ramp up our courses much faster than we could without that department structure. Finally, you'll hear a lot more about how we're innovating in our undergraduate program. The first thing you know is we turned the curriculum upside down and we have you start with linear algebra instead of calculus. And we've been co-teaching that course with other schools around the country, including some that are historically Black colleges and universities, and creating an environment for our undergraduates that's built on partnership and collaboration. We want to infuse those values of diversity, equity, and inclusion throughout our department in the undergraduate and graduate program. And we want you to work together with your other students, with help from the graduate students and the instructional aides and the faculty, so that everyone can be successful. All the students who are admitted to Michigan are super smart and inherently capable of succeeding. We are not building any kind of weed out program. We are building a collaborative success program. So here you can see the faculty we have in the department. They have either officially moved or are in the process of moving from their existing departments into robotics. Now I need to get on the communication specialist because we have several new faculty that started last week. Some of them are here and their pictures are not yet up there, but you may get a chance to meet them. Damon's on it. So we will get this slide updated. But I wanted to show you this picture because I think it shows you all the people that we have. I mean, we're interested in robotics and robots are machines, but they're machines that help people. I also like to show this picture because it has all areas of robotics. We've got driving robots, self-driving cars, walking robots, flying robots, underwater robots, manipulation robots, manufacturing robots, and we can probably invent a few more types of robots. So we call this full spectrum robotics. We do all kinds of robotics. We think there are very interesting research challenges across the whole spectrum of robotics, and we hope you'll get excited in all these areas as you go through your curriculum. I mentioned we'd like to try to define the discipline of robotics. So this is our definition that we're working from as the study of embodied intelligence. So that body is really important. This is not just artificial intelligence. This is artificial intelligence embedded in a physical system that can sense its environment and interact with its environment, including people. Even autonomous vehicles need to be given directions and goals from people. They don't do their own thing, at least not yet. We also have a set of values in the department that I hope you will all embrace. The first is robotics with respect. We expect all members of the department to treat everybody with the utmost respect. Other students, teammates, teaching staff, technical staff, cleaning staff, random visitors to the department. We get a lot of those, everybody. The second is enthusiastic outreach. Now you all know this, robotics is fun, it's exciting, and it's a great way to get young people excited about math and science. We do a lot of outreach activities to get kids excited about robotics and math and science and engineering, and you will have opportunities to participate in some of those programs, I hope. Finally, integrity in action. If robots are really going to serve society, if the self-driving car can get your grandmother to her doctor's appointment, we need to design and build these systems with integrity at the very forefront. We expect our community to be honest about what their devices can do and what are the limitations, because let's be frank, no robotic solution we come up with is going to solve all problems. There's always going to be some limitations. We want to celebrate the amazing things that our robots can do and acknowledge the things that are still open problems to be solved. Now, maybe this is why you're here. Many of you participated in FIRST Robotics or VEX Robotics while you were in high school. Michigan in particular is a super hot state for FIRST with more teams than any other state. It's fun and exciting. And we want to build on that experience and teach students the fundamentals of robotics so they can go to the next level in their undergraduate program or in graduate school. Or maybe this is why you're here. Robotics is super hot in the job market as well. Our master's graduates have had no trouble finding very well-paying jobs, doing very interesting things in industry, and we expect very similar outcomes for our undergraduate students. So that's the end of my intro. I'll be around to answer questions after. I'll turn it back over to Chad for more details on the program.
All right, thank you so much. Yes, let's think. Done. There we go. A fabulous introduction to an overview of our robotics department and its growth and potential for the future. And so I'm gonna hide these floating meeting controls real quick. All right, and so now in that context of the robotics department, I'd like to talk about the robotics undergraduate program, which is the reason why you're here. And I would just like to first start off by just showing me and Kim right here. That's Kim Hambikin at NASA. And Kim and I, it's an interesting fact. Kim and I, we were born the same year. We both got our PhDs in the same year, and we've had the same opportunities. We're both roboticists. So she works at NASA Johnson Space Center with the Valkyrie robot right here. And so for us, you have more opportunity than we had moving forward. And so now just as a quiz, so for first quiz, you can't be in this classroom without at least one quiz. What was before 2022, when Kim and I were students, what was the best major to become a roboticist? Any guesses? Yeah, Justin. Electrical engineering. All right, maybe that was the best major over there. Mechanical engineering. Ellie, yeah. Computer science. All right, and any other guesses? What was the best major? Yeah. Computer engineering. Now that I have to say, computer engineering is very close to what we do. There's a lot of great computer engineers that come into roboticists. If you remember what my colleague Professor Tilbury said, the best major was actually a quadruple major in math, CS, electrical, mechanical, with our minor in psychology. So that's really too much to pack into 4 years. So and we're really trying to give you continued growth into the field. And one thing that we've also seen, we've just seen so much energy for robotics on campus, such as through FIRST. And so last Saturday was the launch of FIRST Robotics, the competition. And we saw people from all over come, a bunch of high school seniors and juniors that are looking to do robotics at the next level. And we want to be able to inspire them from day one, create new opportunities for them, and then also create a great community, an active community for engagement and learning. We're not just thinking about what's happening, as was said in the context of the department. We're not just thinking about what this looks like for just the environment on campus, but what does it look like for your entire career? What does it take to work with our partners at the K through 12 level, at the elementary and secondary schools, such that students are ready to have a great experience here in the campus environment. And then once you're here in our undergraduate and graduate programs, how can we help you have sustained success in the robotics and AI workforce and be the innovators and leaders of our field? And so with that, we've created a first of its kind undergraduate degree program. And so we've really had 3 pillars that build on the values that were stated, that we want to define the discipline of robotics. What does it mean to be a roboticist? When somebody hires a roboticist, what do you really get? And what we're seeing is lots of demand for that. We want to be able to innovate for equity and be able to both produce, improve the productivity and quality of life of people across society, and then meet the emerging needs that we're seeing in society. You should note that it wasn't just the robotics program just showed up. You're building on a long history that's come from robotics that dates back from the Computer Information and Control Engineering graduate program back in the 1960s, and even before that. But we've seen the launch of the robotics graduate program in 2014, and we're building on that success in order to offer a lot of those same access into robotics to our undergraduates now. One of our major goals for this is to basically graduate skilled roboticists in 4 years. And so there's many different pathways that you could have into robotics. Traditionally at Michigan, since we've launched the graduate program, this is more of like a 6-year program. You would do computer science or computer engineering, mechanical, electrical, aerospace, industrial engineering, and or biomedical, many of those different majors, and then do the master's degree for 2 years. And so we've seen those graduate graduates be incredibly successful. We're bringing that now into the undergraduate level, and we're doing that by taking topics that would typically you would not get exposure to until graduate school or until your senior year, and elevating them into the year 2 and year 3 experience. And so this is basically doing things like autonomous navigation, like what Professor Skinner here teaches in Robotics 330, robot manipulation and kinematics, which I would cover in Robotics 320, and the fabulous ball-bot course that Professor Rouse here teaches for robot design and building, among many other topics that we're going to be able to get greater exposure to. And this will hopefully grow opportunities across the College of Engineering and other different paths of study. Everything that you need in order to get started with our program and to craft your degree program can be found on our website, and in particular the program guide. And so that really is the word when it comes to the program and how you can participate. One particular part that's of interest is the robotics major degree flow. And so this basically gives you, this is a diagram that lays out a sort of schema for how you can plot your pathway through the robotics program. And just some highlights of this are that in our first year, as Professor Tilbury was saying, we're covering full spectrum robotics. So that is, how can robots sense the world using linear algebra as the mathematical foundation? How can your robot plan and reason to make actions in that world? That's through introductory programming, and that really is covered in Robotics 102. And with Professor Yeo, you can learn how to build robots and actually have them move around in the real world and take actions. And that is Robotics 103, or you can take that as Engine 100 850. And so this really gives you the opportunity to work with robots from day one. Our gateway into the major is the Human Robot Systems course. And so one way to think of this is, how can you work with people to design robots for people? So we can develop all sorts of great technical capability, but you'll be spending more of your time communicating with people in a team and understanding what you are trying to build. And so this is Robotics 204. Those and in addition, there's other 200 level courses that we build from across the college that cover the data structures for computing, probability, which is for an uncertain world, our robots have to be able to basically understand the mathematics for probability, electronics, so how we can wire up our robots and have them function, and mechanics, so you can model and control them effectively. From those 200 level courses, that builds out into our 300 level courses, where we cover a wide where we cover a spectrum of different approaches, different topics that you need to be a successful roboticist, from robot design and hardware, the circuits of the robots, kinematics and planning, autonomous navigation and perception, as well as robots to help people through human-robot interaction. And so these are just pictures from a few of those classes that are good. From these, because you only have to take 3 out of 5 of those courses, these sort of enumerate into helping you define what your path could be. You'll notice in our program guide, we don't just have 1 sample schedule, we have 4 sample schedules that you can look at as ideas for what your path could look like. And so these sort of enumerate different kind of threads through our program. You could be a more empirically focused human-robot interaction. So you're studying how robots work with people. There's a pathway for that. You could focus on the autonomy of robots, and on the computational elements. There's a pathway for that. You can focus on robot hardware and design and building those actual robots. There's a pathway for that. And if you want to take all 5 of our 300 level courses, that's really the pathway for being a well-rounded roboticist. And so you can sort of, choose your own adventure with this. We're building out right now a number of electives at the 400 level, at the upper level, that would allow you to deepen your knowledge in robotics. And so these build on our focus areas. So if you look on our website, we cover topics such as perception and manipulation, robot swarms, bipedal locomotion. There's a number of different courses that we're building out right now. These are sort of, right now we're still going through the design of the upper level. So we're offering some courses. I think I see at least 2 students here that will graduate with Robotics Majors this year. They're finding their way through, but for the students that are coming next year, we'll have more of these courses in place. But this is just a listing that gives you a sense of what's coming along. And at the end of it, what we're going to have is a capstone experience. So this is really where you take everything that you've learned through the program and you go through a 2-semester capstone sequence to help you solve a real world problem. And so part of this is in what you're going to do. You can take what we have you doing is taking TechCom 350 to start off with, so you can study a very simple problem, but understand the design process and how you can work with clients to solve a real world problem. And then you'll take that knowledge into Robotics 450. Professor Kira Barton is slated to teach that. Our initial offering that in winter 2024. That will actually, where you'll actually work with real clients to solve a problem that they have using all the mastery that you've gained in the robotics undergraduate program. And so oftentimes we get a number of questions. We get a lot of questions about when will we offer a robotics minor, a SUGS for master's degree for robotics, dual degree options, transfer credit options, study abroad, co-op semesters, and it's just a small list. There's actually many. We're still in our startup mode, so we're not really addressing one of those, except just recently we had what I think we are anticipating being able to offer a SUGS into robotics for robotics majors for fall. And so we can hopefully be able to have that in place. We're still in the early stages of going through the approvals for that, but we're hopeful. So we're getting to this list. That's a big deal, right, Professor Grizzle? That's a big deal. Did I hear a woo for that? Yay. Great. All right, I'm not going to say anything about still living in the 90s then. Anyway, so coming back to me and Kim here, is robotics the right major for you? Should you be thinking about that quadruple major with a minor in psychology? Actually, you don't really have to. The robotics major is really for students who want to do robotics first and foremost from day one. This is their calling. But you don't have to be a robotics major to study robotics. There's all sorts of other majors. We've been training great roboticists for decades who have come through other programs, and so you could do X major and then do a robotics master's, apply to our robotics master's program. That's a great pathway. You could do some engineering major with some combination of robotics courses. There are a number of concentrations that are coming up. So you could do a mechanical engineering major with a robotics concentration. I think we'll very soon see other majors with robotics concentrations that come with that. Traditionally, as a computer scientist, we've had computer science and computer engineering majors that have come through and then taken ECS 367, 373, and 467 with some AI on the side, and they've been incredibly successful. And also, you don't have to have formal, if you want to do the experiential learning route, you could be whatever major and then do a student team like M-Rover or MAV, Baja Racing. These are great ways to do this. And so at the end of the day, you have to listen to your instincts about what makes sense for your journey, your scholarship journey. One thing that we did, the number one question that we got last semester as we were ramping up is, what can I do with a robotics degree? And so we had 7 great speakers. These talks are still online and you can find them on the robotics website. And so we asked them, what was your pathway into robotics? And so we had people from Ford Motor Company, Toyota Research Institute, Amazon, NASA, NVIDIA, Google, and JP Morgan. And so this gives you a sense of what your pathway could look like looking at these examples right here. And robotics majors are on the rise. And so this is just a plot of the majors since our time. You can see that you are definitely not alone. So as of yesterday morning, I think we're at 61. That number may be higher now, but you can see that big spike right there in early December as students started getting past linear algebra. They fulfilled that requirement and then zoom. And so we have a lot of majors who are here. There are ways for you to get involved. And so one way that's great is through the Robotics IA program. So you can be on the core staff and help out. Applications will open later this semester, probably the March timeframe. One thing that really the character and the integrity and the quality of our program really relies on the students more than anybody else. And so the community that you provide will be reflective of the culture, the academic culture that we have. And so Professor Skinner is leading the formation of our undergraduate organization, our planning committee. There will be a meeting coming up next Thursday, if I'm not mistaken. So Kayla will talk a little bit more about that. And so we need your help to be able to make sure that we're representing the students, that you have a voice in our program, but we're also open to new ideas from across our robotics undergraduate community. So feel free to reach out to myself, Professor Tilbury, Kayla, or any of our faculty about ideas that you might have so that could improve our community and make it an even better experience. And so with that, I forgot to say, I can't underscore enough how being a robotics IA is really important. Yeah, there we go. There we go. Can I get a whoop whoop from all my IAs in the house? Woo 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 woo. All right, there we go. I won't call you out too much. But if you like our classes and you like the feeling that you get in the classes, especially at the 100 level as you come in and through our 200 and 300 level courses, the best way to help out is join our staff and help the next generation come through. And so I can't, this is from Robotics 102. This is me and some of the students. I think we provide a good environment. And so really work with us. You know, we are a community together, faculty, staff, and students. And so with that, I'm going to now pass to Kayla Dombrowski, who's going to talk a little bit about undergraduate advising and student support.
Thank you. So I'm going to go over more of like the logistics on how we run the undergraduate program. We have a team of faculty who are serving as advisors, and soon we'll have a undergraduate staff advisor. But when you schedule an advising appointment, you're going to be meeting with these folks. So they're the experts in their field, so they can really give you the information that you need and can talk you through what your interests are and how that can translate into courses. To schedule an advising appointment, we use the same setup as the Engineering Academics Advising Center. So you're all familiar with that from your first year studies. You can go on the website or use this QR code and click robotics. And then these are all the reasons why you can, these are some of the reasons. This is not exhaustive. So you can meet with an advisor and talk about anything. Talk about the major, declare your major, come in for your senior audit. So I know we'll have 2 this year. And then just general advising questions. If you are interested in an internship and you want to talk through an application, if you want to learn more about what that faculty is researching, you can schedule an advising appointment for that. This kind of serves too as a bit of like an office hour. So make sure that you are scheduling an appointment. And if you can't make it, you are canceling it, because we do have a lot of students who do want to meet with our faculty. So we want to make sure that the faculty's time is important and that your time is important, and those students who are trying to get into appointments too. If you're considering a major and you kind of want to see how the classes you've already taken would come into our program, you can run a what if report. And this can be accessed in Wolverine Access in your Student Center. You'll just click the drop-down box and do what if report. And you can also use this if you're planning on doing a double major or a minor. You can put all of the departments in that you are interested in pursuing a degree with, and that will populate a degree audit. So this is what the university uses to make sure that you completed all the requirements, you can graduate from the University of Michigan with your degree. So you can see here how the classes pull in. The bolded classes are classes that are currently in progress. And then at the bottom, this is just the robotics requirements. At the bottom, it has a list of all of your classes. So you can see if a class isn't pulling in properly, and you can petition our department, or you can just send us an email and say, why didn't this class count as an elective? And we can figure that out for you. So we have a lot of demand on our courses. So if you are on a wait list, please be patient. We are going through all of the wait lists. As soon as seats open up, we issue overrides. The Wolverine Access system does not account for, so if you see that there's an open seat, it doesn't account for permissions that have already been issued but have not been registered with yet. So just keep that in mind and have a backup plan. We will continue to do this up until the drop ad deadline, but we want to make sure that you can fulfill the requirements. So if you can't get into a robotics class and you're planning on majoring, or you are majoring, please let us know so we can do our best to accommodate you. And we are still waiving the 204 requirements for the 300 level courses. So if you're interested in enrolling in one of those this semester, please let me know so we can get you enrolled in one of those too. And then you can reach us at ugrad-robotics@umich.edu. I answer all of those emails. So you can either, if you send it to me, I do try to forward it there so we can keep a log of all the emails. So if you send it to me and I'm responding from UGrad, that's what happens, just so that there's a running record of all of the questions that we get in. Professor Jenkins mentioned our student organization. We are developing a department-sponsored student org. In order to participate, you do need to be declared or are declaring this semester. We're hoping to have a planning committee this term for an active student organization in the fall. So here's a QR code to a Google form. If you're interested in participating, you can fill that out and I will send you the information. We are meeting next Wednesday. So I will send you that information. And the first meeting is just to gather, collect information from you all about what you feel is important to a student organization, developing leadership roles, and then creating the planning committee and what the next steps might look like. If you are not a major yet, but you want to stay in the know because you're still on the border and you're considering declaring, you can join our undergrad info group or be on the Piazza webpage. So for those of you in the room, you're probably already associated with those because you're here and that is where we posted this information. So great job. But continue, if you have students who you know or friends, make sure that they get on the email list and we'll make sure that they get the information that they need about the department. Okay.
All right, thank you. Let's thank Ms. Dombrowski. All right, so now I would ask all our faculty to come up and we'll do a fast forward. Just stand over here and we'll do fast forward of courses, or you can come up as needed if you want. I don't know what the order is, but now we're gonna just for everybody here and all the people online, we're gonna do just a fast forward of courses, 60 seconds highlights of what you can expect in each course to give you a sense of what's coming. And so with that, I'm gonna I don't know if I need to time people or not, but we'll start with Professor Grizzle with Robotics 101, Computational Linear Algebra. Mark, get set, go.
1, 2, 3, go. So as Professor Tilbury mentioned, the big thing with Rob 101 is we flip the order. It comes before calculus. If you come in and you've already had some calculus in high school, it's okay, but you'll appreciate calculus a lot more with the vision that we will actually give you. We are marrying theory with computation so that everything you learn as a formula, you implement in code and see it from 2 different points of view. And the code allows us to do examples at the scale of life. So you'll be working with vectors that have 300,000 elements in them, okay? You're not going to do that by hand. The final thing we're doing is we are promoting opportunity and equity. So I've even had high school students in the course. We've had students from Howard now, from Morehouse, from Spelman and Florida A&M, and we're looking to add to that.
Excellent. Thank you so much. Let's thank Professor Grizzle. Thank you. So just to also note that course is being offered now, be offered every semester for the foreseeable future. One thing that I am teaching is introduction to introduction to AI and programming. This is first semester robotics course, or a programming course actually. So if you want to take this instead of Engine 101 or Engine 151, you could take this course. And what we do is we essentially teach you C++ programming with a little bit of Python or Julia, depending on either to essentially show you an introduction into programming through autonomous navigation with an OmniDrive robot right here. And so this should note fulfills the prerequisite for ECS 280. So you can take this course and be ready for the first semester data structures course. And so learn how to code by making robots navigate autonomously. All right, moving on. Our Professor Yeo.
Thank you. So I run Rob 103. It's cross-listed, used to be. We're really running Engine 100 850. The idea with this course was to have everyone build their first robot, whatever that robot might be, and make it work, or at least make it work at least once while you videotape it, and then you show that off at a presentation as though it was a normal thing. And so that's Engine 100 850. The idea is build a project. It's important to kind of create something that you're interested in doing, because that way you kind of see the value in it, even if there isn't that much value in it. And so there are another concept with robotic mechanisms is mechanisms are more than just physical things. It's 2023. Mechanisms are made of computers, mechanisms are made of electrons, and sometimes even, I don't know, transistors, whatever these are. So the idea with mechanisms, the idea that we have the course is to introduce everyone to some element of the processes and the systems that kind of conspire to make some robot do its thing. I think that's
All right, let's thank Professor Yeo. Yay. All right, and so next we have Robotics 204. Professor Sterling couldn't be here, but really this course is about how I like to call it, how do you work with people to develop robots for people? And so this is identifying how humans describe capabilities and behaviors to inform robotic design. So think about this as a design course. And then really thinking about the human user, how are potential users going to be able to work with this robot, and how do you evaluate that? And so there's a number of different topics. I think one thing that Professor Sterling would like to emphasize is the socially engaged design. And so how do we really think about that? And so this is our gateway course into the major. You have to take 204 before taking the 300 level courses, because we want to make sure that you are a responsible, capable individual that's going to take all the power of robotics and do things the right way. And so with that was 204. And so now we will talk about Robotics 310. Is Peter here? Peter's not here. All right, I'll talk about this course too. And so Robotics 310 is really our core sort of circuits course. So how do we start to think about analog design and digital design so that you can make robots, so you can do the circuitry that make robots actually function. And so we study this through how do you develop an inertial measurement unit, how do you build a simple range sensor for a robot, and then also a little bit of filtering. I forgot so IMU, a range sensor, and then there's one more, I think an analog to digital converter. And so those are the topics so that you're not afraid of making robots. The way I, as a computer scientist who's become a roboticist, I'm afraid of touching hardware and soldering things. You should not feel that way. So this is the course that really allows us to do this. And so now I will pass to, oh, we lost Professor Rouse. Okay, I will talk about Robotics 311. So Robotics 311 is a build robots and make them move course. And so this is really a robot design course. How do you think about how can you use the shop and all the facilities in the shop to be able to design a robot? You do use all the machinery there to cut out the robot, assemble the pieces together, make sure that your design works. And you explore this all through making a ball bot. So just as I don't watch Star Wars, I have to admit, sorry about that, but like apparently a lot of people like Star Wars, and this is sort of like your ball bot from Star Wars. And so we just ran the first instance of this class, and we have some students who took that class, and so it's great to see the demo day and see tons of the robots like this moving around our building and having a great experience. All right, one more course. So one course I'm teaching this semester, which is Robotics 320, which is really kinematics and planning course. How can we model and control a variety of different robots? So how can we go all the way from doing path and motion planning to getting this to work to develop a full stack software system so that you can represent any robot and be able to do pick and place. So robot can move its end effector here and pick something up and move that object somewhere else. We do this by looking at the systems aspect as well. Students always ask, can I learn ROS, the robot operating system? We will cover that in this topic as well, which will give us a mechanism to do inter-process communication. With that, I will pass to Professor Skinner.
Hi, I'm Professor Skinner. I teach Rob 330, which is our SLAM and navigation course. So we just did the pilot course offering this fall. I see a couple of familiar faces. I feel like next time we can make you describe the course in these lightning rounds. But for now, I'll say that this course covers everything robot perception. So we cover localization, mapping, and autonomous navigation. We work with a couple of different types of sensors to do state estimation and particle filtering and occupancy grid mapping. So this course is really meant to be kind of a jumping board for going into any area of robot perception that you might be interested in, learning a little bit about deep learning, a little bit about computer vision, and a little bit about probabilistic robotics as well. So hopefully this is a good foundation for you to go on to any class at a higher level in perception.
Excellent. All right, let's thank Professor Skinner. Want to say a little bit about 340? Excellent.
So building on 204, the gateway class, human robot interaction is something that we're developing, which will handle yet more of how a human interacts with a robot. Human thinks differently than a robot. Sometimes a human can't even describe how or what they're thinking. So you'll be designing experiments in order to determine, even if they can tell you what is really going on in their heads. That'll be part of, so cognitive mechanisms will be part of the context, the design of experiments to evaluate the performance of both the human and the robot, and the human and robot working together as a team. So we'll be building on what you've learned in 204 to talk more about behavior, both as viewed as if it were a human or the robot or a team again. So measuring human perception, modeling the human operator within the control loop, and then other things that we're going to bring in have to do with the mechanics of interaction between a human and robot when a contact is involved, when forces and motions are things that you can characterize at that point of contact. So how is power being exchanged between the two when they're contacting one another? And that all falls under the heading of physical human-robot interaction. So both in the physical sense and in the sort of cognitive sense, human-robot interaction contains many sort of subfields, and we'll give you an overview of those.
All right, Professor Gillespie, let's give a hand for Professor Gillespie. Excellent. And so algorithmic robotics, this is a course taught by Professor Berenson. So this is a course that covers sort of the wide variety of robotics at a very sort of very theoretical level. So it's going to cover things like filtering, cover path planning, cover bit of optimization. So you get a touch on sort of everything in sort of the algorithmic foundations in robotics. And so that course is there. Professor Gerard Anouk, you happen to be online?
Yeah, I'm here.
All right, the floor is yours.
So 495 is a course on flying and swimming robots and how you move through liquids. And so it covers dynamics, control, and propulsion strategies for the robots. And so we'll derive equations of motion and look at disturbance models for robots that fly or swim at different scales. And then we'll look at different maneuvers or modes that those robots operate in, such as gliding, soaring, hovering, buoyancy control, that kind of thing.
All right, excellent. Let's thank Professor Gerard. Kira Barton, I don't know if Kira is online. No, Kira. So this is our capstone course that we're sort of talking about before. This is the course that brings everything together, working with real clients to take what you've learned in this class, also learned through our program, as well as through technical communications, to be able to do to build a real system. This is where you learn how to be a pro in robotics, essentially. Bobby, is Bobby on? All right, Bobby, can you talk a little bit about 510?
Sure, I'm on. So this is a class about robot kinematics and dynamics, and also control for robots. So we talk about the mathematical tools needed to model the kinematic motion of robots, so where they are in space and the orientation as well. And then to derive the dynamic equations of motion, and subsequently determine control policies that will be used to command the actuators to make them move in the environment. So that's the summary of this class.
All right, excellent. Let's thank Professor Gregg. Typically a winter course, and also we should note that a lot of our courses that you'll see at the 500 level are oftentimes also available to seniors in our program. And so as we build things out, you'll probably see a lot of combined 400, 500 level listings. There's also a motion planning class that's offered by Professor Berenson. So this is really thinking about, so if you take Robotics 320, you take some of the algorithmic robotic courses, you get a small taste of what motion planning could look like, but there's a wide area out there. And so that's basically generating collision-free paths that allow robots to move in space, but also make proper contact so that you can manipulate various objects. We also have Robotics 530 that's on here. really, this says mobile robotics, but really what this is a probabilistic robotics class. So if you take a number of our classes, you see sort of your baseline particle filter, you see your baseline occupancy grid mapping, but there's a whole other world out there that includes factor graphs and various different ways of thinking about probability for robots to reason in an uncertain world. And so Robotics 530, as well as its 400 level accompaniment that will come soon, will be able to give you entree into those probabilistic robotics courses. Anouk, would you want to take autonomous vehicles?
Sure, I'm teaching it this semester and I'll teach it again in the fall. So we're going to switch which semester it's offered in likely. Okay? And so what we do in the class is we talk about autonomous vehicles, we cover some history and some challenges with both perception and control for autonomous vehicles. And then we go through 4 basic modules. Control, where we basically work the theory up to implementations of model predictive control. Trajectory planning, state estimation and localization, and then computer vision. And we use self-driving car examples as our motivation throughout. And there's a project at the end where you get to race cars in simulation around a track while avoiding other cars.
All right, thank you. Let's thank Professor Gerard. So there's bio-inspiration. So this is a bio-inspired design class that's offered by Professor Moore. Really, a lot of times what we're doing in robotics is we take inspiration from biology. We use that to build robots, but we can also use our building of robots to get notions and better understanding of what how biology works. And so this is a course that thinks about all the different types of mechanisms that have arisen in nature, and then being able to apply them for robotics cases. So this would be like jerboas and gecko robots, insect robots, and all sorts of interesting designs that come from nature and applying them to robotics. There's an ethics and robotics course, and so ethics and AI and robotics. So as we build these machines, what are going to be the ethical considerations for how we use these types of robots and how we engage with them, and the types of things that they're going to think about in terms of trust, safety, privacy, bias, and fairness, and on all of these risks. That course is being offered in this semester in the winter, and probably a little bit in a few more semesters after that. Probably one of the courses that's been around that sort of is different than what people are expecting. I don't know if Cindy's on. Is basically neurorobotics, and so these are essentially robots that can be controlled by the brain. And so this is really an interesting approach for how we think about decoding the signals in the brain and then using that to control robots. Sort of like, another part of Star Wars that I've seen is the Luke Skywalker hand, when he has to get that built back. Do people remember that? Or is that the 70s and people don't remember the 70s? I don't know. But basically, how can you build brain controlled robotics prostheses or use other signals from the body in order to control robotics prosthetics? And so this is offered by Professor Chestic in the winter semester. I will pass to Professor Skinner, who can talk about 3D perception.
3D robot perception will be a senior level course that kind of builds on what we have taught in 330. So this course will focus more on 3D perception, which really means expanding to stereo cameras, thinking about how to perceive 3D environments versus the 2D occupancy grid maps that we did in 330. So if you are interested in kind of the vision aspects of that course, then I think 3D robot perception would be a next step for you.
Excellent. Thank you very much for Professor Skinner. Let's give a quick hand for Professor Skinner. Yay. I even though I don't work in SLAM and perception, I think this is, or I do work in perception, but I don't work in SLAM. I think mapping is one of the coolest things that when students see it, it's just like, oh wow, I didn't realize we could do that. So that's kind of cool. Professor Draelos.
Thank you. So Concepts in Medical Robotics is sort of a senior level, graduate level course that we're launching this semester. It's an introduction into how robots are used in healthcare, especially in medical clinical environments or surgical environments. The structure of the course is based on a sort of history of medical robots. We then do a crash course in anatomy and physiology, then do modules on manipulation with a focus on surgical applications, control of medical robots. In the second half of the course, we'll spend time going to the simulation center at Michigan Medicine, and then take class projects looking at specific medical robot systems. We saw the Da Vinci on the previous slide. We'll take a close look at that one as well as others that you might find actually in an operating room or a clinic today.
Thank you very much. Let's thank Professor Draelos. And it's a special privilege. This is very new area for us in robotics. So I would try to take advantage. And if there, I believe there's still time to sign up for your classes, or yeah. So I would take advantage and join if you can do that. Experimental UAS.
So this course is about creating an autopilot for flying vehicles. It turns out flying vehicles have a unique set of challenges. It's not particularly difficult to fly a vehicle, to have a vehicle fly itself, but it has to do it all the time. This course is mostly split up into two. One half of it is dealing with vertical takeoff / multi-copter type UAVs. The other half deals with fixed wing aircraft. It's really difficult it's really difficult to go out and fly a drone legally these days. And so one of the ideas that we had was to have a little drone stuck in a little stool going around and around in a circle where students will build an autopilot for that crazy little thing that goes around and around. So technically that little piece of fishing line that connects the stool to the vehicle is our legal safety net, because now we're legal. If that breaks, then we go to jail. So that's our
Right. Let's thank Professor Yeo. There we go. All right, legged locomotion. Bobby, Professor Gregg, would you like to talk about this course?
I defer to Jesse unless he's left. I'm happy to cover it.
Go for it. There we go.
Sorry, who's going for it?
All right, you're going to go for it. Bobby, can you go for it?
Okay, yes. Sorry, Zoom miscommunication here. So legged locomotion is a new course that Professor Grizzle and I plan to develop at some point soon that will cover different types of legged robots, from quadrupeds to bipeds that are human-like to bipeds that are not human-like. So examples you can see in these two videos with a powered prosthetic leg used by an amputee, as well as the Cassie robot that has more bird-like legs than human legs. And so we'll cover concepts for modeling, the kinematics and dynamics of these systems, including hybrid system models that involve both continuous and discrete dynamics to deal with foot impacts. And we'll cover software tools for developing these models, optimizing the gates and designing control laws that will then produce stable locomotion with these gates. So that's a new course that we'll hope to develop over the next couple of years.
All right, excellent. Let's thank Professor Gregg. Just noting that I don't think undergraduates really get to take courses like this. This would be, I think, be something new and special that I don't know if you could find anywhere else. Marine robotics, Professor Skinner, you're back up.
So this course has been offered as a graduate level course, but I'm hoping to offer it to undergrads next year as well. So this is really an overview of marine robotic systems. So we talk about all of the really unique aspects of working with robots underwater. So anything from vehicle design, waterproofing, kinematic and dynamic modeling. We go through the equations of motion for an AUV. And then we also talk about sensing and navigation challenges, like how do camera systems work underwater. We have a class project. You can focus on either design or algorithm development. So if you've ever thought about maybe sending the MBOT to the bottom of the ocean and recovering it, this is your chance to figure out how to do that.
Excellent. Let's thank Professor Skinner one more time. All right. Mika, is Mika on? So multi-robot system. So this is a new course that we're rolling out from Professor Panagou. And so this is how we start to think about coordination of robot swarms and teams of robots. And so how do you think about these, the sensing model and communications for how you can work with these systems, thinking about coalitions and formation control, and then also different types of optimization algorithms that you could think for that make sense in this context. And so this will be a new course that we're hopefully going to roll out either next year or very soon after, hopefully next year. there's an optimal robotics course that's being considered. And so really, what does optimization, all the methods for optimization look like in the context of robotics for controlling robots such as a car on ice right here, but also thinking about human motion and being able to estimate. And so really we have, so optimization is a major tool, a major sort of source of capability for robotics. So how can we start to think about that in this context? And so Professor Vasudevan will look at that. Then we're also creating a new robotic control course, building off of those ideas, building on a similar idea as well. Professor Gregg, I believe, is going to help us create that course. Bobby, can you say a few words?
Yeah, this is going to be a new style of controls class, unlike what you might take in mechanical engineering or electrical or aerospace engineering. We're not going to just start with the whole semester frequency domain control system design. We're going to be dealing with state space models that can handle both linear and nonlinear systems because of the fact that robots are highly nonlinear. We'll be talking about optimal control for robotic systems, under-actuated robotic systems, which that means robots that have more degrees of freedom than actuators, which makes them more difficult to control. We'll deal with model predictive control methods, as well as elementary nonlinear control methods as well.
All right. Thank you very much. Let's thank Professor Gregg. Yeah. A controlled course for roboticists by roboticists. We should keep that in mind. Thank you so much. There is a control learning course that's being offered this semester. I believe, I don't know if we've hit the limit in terms of enrollment this year, so you can try to take that course. This is really thinking about machine learning from the perspective of a roboticist. And so there's a number of topics. There is sort of a large collection of topics that are being covered in terms of representation learning, sim to real, policy learning, controller learning, dealing with uncertainty. I believe there's a learning from demonstration part that's coming in there. And so really thinking about how do we control these types of robot arms using from the machine learning perspective. There's a space robotics course. Anouk, you want to, Professor Gerard, you want to talk a little bit about this?
Yeah, sure. The class hasn't been taught yet, so it's not entirely clear what it is we're going to cover yet, but it's clear that space robots excite a lot of imagination in the public, and they're really cool. And so we'll talk a little bit about what makes the space environment special and why it's interesting and difficult for robots in some ways and perhaps easier in others. And then we'll talk about different missions and navigation and control and planning strategies for all the different missions.
All right,
and
thank
my
you.
goal is to use a different mission every time we offer it, actually, to make it interesting.
Very cool, very cool. Thank you for the thoughts into the future, Professor Gerard. Let's thank Professor Gerard real quick. But really, all of you have come for this presentation from one of our new faculty members, Professor Sean Huang, who is talking about a soft robotics course.
Thank you. So I'm Professor Xiaonan Huang. You can call me Xiaonan or Sean. I don't have any preference. So I'm teaching soft robotics this semester. The goal is to develop like soft and movable machines that can like navigate through unstructured terrains, confined spaces, or like connected pipelines. So you will be like split into teams, build soft robots from scratch, and like compete on a like soft robot terrestrial race court. And the winning team will have the opportunity to attend the like IEEE RoboSoft race competition in the following year. So we'll also have like a selection of like lectures and guest lectures. Like we will cover kind of like the most recent paradigms in soft robotics, including like soft multifunctional materials, artificial skins, artificial muscles, and like soft robotic systems. Yeah, it's a fun course.
All right, let's thank Professor Huang. And I just wanted to emphasize, this is really a very hot area, very new. We're very fortunate to have Professor Huang here. And, really the types of robots that we're thinking about that are sort of the rigid, typical robot, we're moving increasingly away from that to something that's compliant and can work with people. And so I would recommend, you still have slots in this class if people want to take it. All right, so people can join in. And so there's also coming up a tactile robotics course. Nima's not online, is he? I'm assuming no, yeah. And so tactile robotics. So a lot of times when we think about perception for robotics, we're thinking about those from the camera perspective, some sort of external perceptive device. But the robot can touch things, and so as the robots are interfacing or physically touching different objects, how can you think about that as a perception mode that would allow robots to function properly? And so this is really thinking about contact as an important sensing modality for robots. So with that, I would like to thank our faculty one more time. We have an amazing set of courses, so let's give our faculty one more big round of applause. Thank you. So for those of you who had stayed and given us the last hour, thank you so much. We really do appreciate it.